Let's take a look at how recent innovations in dating methodology helps our understanding of early cave art. Cave paintings first appeared in Europe and are associated with early modern humans, not with Neanderthals. The oldest radiocarbon date for Paleolithic cave art was 38,000 to 35,000 years before present, from Chauveau, France. Cave paintings are significant as indicators of early complex symbolic behavior. Often they depict animals, though many are geometric and figureless. The meaning of cave art remains mysterious. In June 2012, researchers published in Science results of U-series dating techniques of Paleolithic art in 11 caves in Spain. Many of the dates were older than previous dates obtained from radiocarbon techniques. These new techniques can be applied at other cave sites to better understand the meaning of chronology of cave art. Radiocarbon dating involves monitoring the decay of carbon-14 to nitrogen-14. This decay occurs at a known rate. It takes 5,730 years for half the amount of carbon-14 to decay. By measuring the ratio of remaining carbon-14 to nitrogen-14 in a sample and considering this known half-life, it is possible to assign an absolute date to a carbon-bearing substance. Because of the relatively short half-life, radiocarbon dating is most effective up to approximately 70,000 to 50,000 years before present, which encapsulates all known modern human activity in Europe, but not all of the activity of genus Homo. Radiocarbon dating is not an ideal method for dating cave art for at least 3 reasons. First, much of the pigmentation of cave art is mineral-based and does not contain carbon. Second, removing pigment that does contain carbon is destructive, and a fairly large amount of material is required for dating. Charcoal must be scraped from the cave walls for radiocarbon dating, which permanently alters the art. Third, contamination is a serious problem for radiocarbon dating, and its effects are amplified when limited amounts of material necessitates very small samples. There's also a possibility that in the future cave art will be found that is older than the effective range of 70,000 to 50,000 years before present. Uranium, thorium, or U-series dating is better suited for dating cave art. This technique monitors specular equilibrium between 2 radioisotopes, uranium-234 and thorium-230. Uranium-234, with a half-life of 245,000 years, decays into thorium-230 with a half-life of 75,000 years. Only until the decay rate of uranium-234 is the same as the decay rate of thorium-230. There is no eventual replacement of uranium-234 by thorium-230. U-series dating is effective up to approximately 500,000 years, which encompasses all Homo sapiens evolution. Uranium and thorium are present in the calcium carbonates that accumulate atop cave art, in the same process that creates stalagmites and stalactites. A very small amount of calcite, less than 10 milligrams, can be scraped from the cave wall for U-series analysis. Scraping a deposit atop of a painting provides a minimum age, whereas scraping a deposit associated with one that underlies the painting provides a maximum age. The new cave art dates are from 11 caves in northern Spain, including the famous site of Altamira. Several dates are older than 35,000 years before present, and one from El Castillo is nearly 41,000 years before present. The more precise dates reveal that the oldest images were simpler than the later images, showing developing complexity over time, whereas the oldest, pre-Gravitinian images are monochromatic and figureless. The younger images are polychromatic and depict animals. This type of accurate chronological sequencing was not possible using previous techniques. Importantly, for understanding why humans created cave paintings, animal depictions apparently were not the earliest inspiration for cave art. Cave art now predates the earliest available skeletal evidence for modern humans in Europe, which was pegged at up to 40,500 years before present from Oase, Romania. This has two implications. First, the researchers do not rule out the possibility that Neanderthals are responsible for the cave art. Neanderthals were present in this region of Spain until approximately 42,000 years before present. The cave art is thus between the previously known date ranges of Neanderthal and human occupation of the area. Finding even older dates for cave art in the future would support this possibility. Second, it may imply that humans already had a tradition of cave paintings before they arrived in Europe. It was previously believed that something about the new European environment catalyzed this complex behavior. It is also possible that cave paintings developed very quickly with humans arrived in Europe. Whether modern complex human behavior developed gradually or arose abruptly around 50,000 years before present is hotly debated. Along with cave art in Europe at the time of human arrival, some exciting new tool finds show signs of complex behavior from Border Cave in South Africa, dating to 44,000 years before present. Seems to support the rapid change hypothesis as well. Some earlier complex behaviors in South Africa, dating to 75,000 years before present, appear to have disappeared around 60,000 years before present, leading some researchers to conclude that complex behavior developed in waves, disappearing and reappearing at times. More evidence from the period between 60,000 and 45,000 years before present is needed to improve our understanding of when complex human behavior arose. It is possible that improved dating will place some of Europe's known cave art into this time frame.